Good evening, dear students. Today we will be starting a new topic called ellipse. That is in continuation of our discussion on conic section. In earlier, we discussed with parabola. That was one type of conic. And today we are going to start, um, you know, a new topic of a conic that is called ellipse. Now, if you recall, dear students, when I discussed about that conic sections and the fundamental understanding about conics, we discussed that in two different approach. One is that how a double flapped cone is actually chopped up by a plane, and the orientation of the plane by which it is chopped up, that different kind of conics. Either it could be a parabola or ellipse or circle, or it could also hyperbola. And also we discussed another point that is called the locus, from a locus point of view. And if you recall that when I discussed about the conic section, a conic is nothing but the locus of a point P which moves in a plane, so that the ratio of the distance of that moving point from a fixed point and from a fixed line is a constant. And if you recall, if that constant is equal to 1, it is known as parabola. Why I'm using the term recall? Because we have discussed it previously. And if you look back to the previous lectures, what I generally shared over a recorded session, which is available in the online platform of conarclasses.com, as well as it is available in YouTube, you will understand why I'm saying so. When the ratio is equal to 1, we call this is a parabola. Which is a parabola? The curve traced by the moving point is a parabola. Now today we are going to discuss ellipse, and we will see that the ratio of these distances is less than 1, and that is called ellipse. Okay, dear students. Now before I proceed further, can someone please confirm that you are able to view the screen properly and able to hear my voice very clearly, dear students? Okay. Able to hear my voice very clearly? Can someone please confirm?
Yes.
Okay, great. So, in introduction, what I can say is that something like this. An ellipse is a locus of a point P which moves in a plane, so that the ratio of the distance from a fixed point S and its distance from a fixed straight line, subject to the condition that the fixed straight line is not passing through the fixed point, is less than 1. Let me write it down, dear students, and then let me explain you further. As you see here, dear students, the write-up, what is visible in front of you. I read out once more that an ellipse is the locus of a point P. Locus. Locus of a point P means what? It is a curve traced out by the point P. And locus is nothing but curve traced out by a point, moving point, subject to the geometrical condition. And here the geometrical condition is that the ratio of the distance of that moving point P from a fixed point S, okay, and from a fixed straight line, this is the fixed straight line, what you see, okay, that ratio is less than 1. That means what? If the fixed point is S and the fixed line, if we define as D1, D2, then SP by PM is actually less than 1 in case of an ellipse. Just a corollary, what we can say is that if that ratio is equal to 1, it is a parabola. And later, when we discuss hyperbola, we will see that when the ratio is greater than 1, then it is a hyperbola. So I hope you got that very basic idea clear about an ellipse. So what is an ellipse, right? You understood. Now, dear student, what I'm going to discuss, I'm going to discuss the general form of, general form, standard form of an ellipse, the way I discussed with parabola. So first I'm going to discuss the different forms of ellipse. And first I'm going to discuss in the different forms of ellipse. So first I want to discuss about the, standard, general form. General form, let me first give you the diagram, and then we will discuss about its equation. Okay, dear students. So first I'm going to show you the general form, and first I want to show you the diagram, how the diagram looks like in a general form. Once we understand the general form, it will be very easy for us to understand any other form that is a standard form generally. Standard form is generally used, okay, generally being referred, but to have a very solid understanding, we need to know that what is the, the general form. And the best way to understand general form is to have a diagram. And as you see, dear students, the diagram is here, and I want to explain you this diagram. Look at very minutely. As you see that OX dash is the x-axis, OY dash is the y-axis, and just visualize there are 3 points here. One is a fixed point, which is S. One is a variable point, that is the P, and another one is a fixed straight line. Actually, two fixed point, I'm so sorry, not two fixed point, one fixed point, one fixed straight line, and one variable point. So what is the fixed point? S is the fixed point, D1, D2 is the fixed straight line, and P is the variable point. And dear students, you know what is AC stands for. AC is known as focus, right? That is very generic. That fixed point is known as the focus for a conic. And the fixed straight line is also known as the directrix for any conic, be it a parabola or ellipse, or later what we'll discuss about hyperbola. It is D1, D2 is the directrix. And what you see, dear students, S is the focus. So what is S? S is known as the focus. D1, D2 is known as the directrix. And dear students, that the point P, that is a variable point. Clear? So now that variable point is actually, it is traced out, it is tracing out a curve. And that curve you see, dear students, in that black color, a oval shape, that is an ellipse. So how this curve is traversed? The geometrical condition is that PS by PM is less than 1. PS is what? The distance between the 2 points P and S. And what is PM? PM is the perpendicular distance from the point P to the line D1, D2, which is the directrix. Correct? So let me write the directrix very clearly. Digital board, sometimes it is not very clearly visible. Let me write it is directrix. Now look at here, dear students. So we need to now deal with two distances, PS and PM. I hope it is clear. Any doubt at any smallest doubt, never hesitate to let me know. Now, dear students, as we are discussing, it is a general form. So we should consider the coordinate of the focus as h, k. So the coordinate of the focus, what we are assuming, S is having the focus, S is the focus having coordinates h, k. And dear students, the directrix D1, D2, okay, let's assume its equation is Lx plus My plus N equal to 0. Correct? So these are the two things, two fixed, entity. One is the focus and another the directrix. And another one, it is a variable point P. And dear students, when there is a variable point, that variable point generally we actually denote it by alpha beta. So the point P, its coordinate is alpha beta. Now, dear students, what we can do is that, as you know, that PS by PM, that also known as eccentricity. If you recall, that PS by PM is known as the eccentricity E. So keeping this in mind, what we can write? We can write something like this. I'm taking it from the study material and show it to you. That we see that PS by PM, SP by PM is equal to E. That means what, dear students? SP is equal to E into PM. That means SP square is equal to E square into PM square. I hope you understood what is E stands for. E stands for eccentricity. Correct? Absolutely clear, dear students? Now, the point is that if you see that SP by PM is equal to E, so SP is equal to E into PM, definitely E is not equal to 0 because a ratio of two distances cannot be equal to 0, hence we can multiply. And eventually, SP square equal to E square PM square. Now, it is very easy to find the value of SP and it is very easy to find the value of PM. Why it is very easy? Because we know the coordinates of the point P and S, so it is not a big deal to find the distance SP square. And also we know the formula, to find the distance, perpendicular distance from a fixed point to a fixed straight line, from a point to a line. No need to mention the fixed one. So PM is the perpendicular distance from the point P to the line D1, D2. We know the coordinate of the point P, which is alpha comma beta. And we know the equation of the directrix D1, D2 is Lx plus My plus N equal to 0. So it is not a big issue to, it is not at all a complex task to, give a, equation of this, SP square equal to E square PM square. And we can eventually write something like this because SP square is equal to, as you see, that alpha minus H whole square plus beta minus K whole square. That is SP square. And E square is already there and PM square is what? L into alpha plus M into beta plus N whole square by L square plus M square. Actually, PM is what? PM is nothing but L into alpha plus M into beta plus N by square root of L square plus M square. But we take a square of this, so we get this one. I hope it is well understood. Now, all we need to do is that we need to make some simplification. First, we make cross multiplication, followed by you can do a simplification. So if we do a cross multiplication, dear students, so what we are going to get? If we do a cross multiplication, we are going to get something like this. So if we do a cross multiplication, so what we are going to do, what we are going to get is that L square plus M square into what we get alpha minus H whole square plus beta minus K whole square is equal to E square into L square alpha square plus M square beta square plus N square plus, A plus B plus C whole square formula we have expanded. It is very easy at this level. Correct. Now, dear students, what we are going to do from this, if you look into this identity 1, how we can get the locus of the point alpha comma beta? Okay, so it is very easy. We just need to replace the value of alpha by x and beta by y. Correct or not? So, dear students, if we make that the value of instead of alpha, what we need to write? We need to write that so what I was telling is that instead of alpha, if we write x, and instead of beta, if we write y, so what we are going to get the equation of the ellipse as something like this. I'm going to show it to you. Dear students, I hope it is clearly understandable. So that is what we understood from the locus. If you recall, dear students, I spent good amount of time, spent in the sense that I told you to look into those video lectures on locus, because in two-dimensional coordinate geometry, understanding locus, having a great understanding on locus is of prime importance. And here, why it is prime importance? Here is a proof. From that identity 1, we are finding the equation of the ellipse, as you see here. What we have done, we just replace alpha by x and beta by y. That's it. And we get the equation of the ellipse we get the equation of the ellipse something like this. Now, dear students, if you recall, the standard form, if you recall the general equation of second degree in x and y. What is the general equation of second degree in x and y? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So if you look into that general equation of second degree in x and y, okay, what we get is that we know what is the required condition for that general equation of second degree in x and y to be qualified to be an ellipse. That value of the determinant delta, okay, that I'm going to show you, that has to be not equal to 0, and h square should be less than ab. So dear students, what I'm going to show you now, here is the statement that we see that the above equation 2 is of the form of a general equation of second degree in x and y. Like what? Like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, where we get the following by equating the like terms, because you can equate the coefficient of x square, xy, y square, x, y, and constant term. You will see that whatever the value of the determinant delta you are getting, that is not equal to 0. And h square, that is coefficient of 2xy. Actually, if I say that coefficient of xy divided by 2, that is h, and product of the coefficient of x square and y square, that is a into b. So we will see that h square is less than a into b. Correct, dear students? So this is what is about, what we can say about that, that general equation of an ellipse. And it satisfies a required condition that a general equation of second degree in x and y to be qualified to an ellipse. Now, dear students, but what is widely accepted and widely used equation of ellipse is that the standard equation, not the general equation. But still, I explained general equation so that you could get a very clear idea that, okay, there is no restriction on the equation of the directrix. It could be anything. Lx plus my plus n equal to 0. There is no restriction on the focus. It could be any arbitrary but fixed point. Arbitrary in the sense I'm telling that there is no restriction on the point h and k. Okay, it could be anywhere, but it should be fixed. Wherever it is, it must be fixed. And we derived that general form. Now, what we are going to discuss, which is most practical and widely used, that is called the standard form. And that I'm going to discuss now, dear students, in the next topic. So we are going to discuss the standard form of an ellipse. If you recall the parabola class, dear students, there also we discussed the general form and the standard form. So here also we are going to discuss the general form and the standard form. We already discussed general form. Now we are going to discuss the standard form. And the most important thing is that to understand all these things by means of a diagram. And here is the diagram, what I'm going to show in front of you, dear students. As you see here, the diagram, very clearly, if you see, here the, the focus, what you see is actually on the x-axis. If you see, dear students, the focus here is on the x-axis, correct? And if you see, if you see that NZ is the directrix. So this is one directrix. So let me write it down. So this is directrix, that NZ. In fact, I can give an arrow because it is a straight line. So this is a directrix. And we know the eccentricity of that ellipse BE. Now, dear students, what we are going to do, we are going to draw ZS. Okay, what is ZS? And that is perpendicular to NZ. So that means from the point S, which is focus, we are going to draw a perpendicular line. Okay, then what we are going to do is that we are going to NZ, ZS we are going to get, and ZS is nothing but perpendicular to NZ. So now what we see is that the ZS, okay, we can divide ZS both internally and externally in the ratio 1:A, 1:E. E is the eccentricity at the point A and A dash respectively. We need to understand this one very well. You see, dear students, there are 2 points. One is the point A and another point is the A dash. Okay, what is that point A and A dash? These 2 points are on the ellipse. That is a curve traced out by the variable point P. Okay, and so these are the 2 points on the x-axis. Okay, so then what we are going to get it, dear students? So if you see the point A, that actually divides that ZS. Z is what? This is the point Z and this is the point S. If you see A divides ZS internally in the ratio 1:E, and okay, the point A dash divides ZS externally in the ratio 1:E. You have a very clear idea about that external division and internal division. Okay, dear students. So what we are going to get? So I'm going to write this thing, and then I'm going to explain you once more. So let me write down the statement from the study material, and then let me explain you. So what we are saying, dear students, so let me write it here. If you look into this particular statement, dear students, let NZ be the directrix, S be the focus, and E be the eccentricity of the ellipse. We draw ZS perpendicular to NZ. We can divide ZS both internally and externally in the ratio 1:E at the point A and A dash respectively. Then we must get this thing. AS by AZ is equal to E, and A dash S by A dash Z, that is also equal to E. So what we are going to get, dear students? We are going to get that AS equal to E into AZ, and A dash S is equal to E into A dash Z. Correct? I hope it is absolutely clear. The point A and A dash lie on the ellipse. Now let C be the midpoint of A dash, and let us assume that A dash is equal to 2A. Why? Because as C is the midpoint of A dash, and if we take A dash equal to 2A, then it is very easy to conclude that AC is equal to A and C dash equal to A. Okay, so this is our kind of an assumption that we are assuming the value of A dash equal to 2A. Correct, dear students? So then what I'm going to write it down? I'm going to write it down something like this. Any point of time, if any smallest clarification, never hesitate to let me know. So let me read it out, dear students. The point A and A dash lie on the ellipse. Let C be the midpoint of A dash. That means what? This is the midpoint. C is the midpoint of A dash. And let us assume that A dash equal to 2A. Let x-axis be along A dash and y-axis passing through the point C. Then we get C as the origin and AC is equal to A, and that is equal to CA dash. Correct? Now, dear students, what we can derive? We can derive the following, that AC minus CS is nothing but, we get AS. So here is a simple, derivation. Let me first place the derivation and followed by, let me explain. Actually, it is very, straightforward. And you can also, it is, in one sense, it is self-explanatory. You can understand by your own. So if you see, dear students, here is that AC minus CS, what we get, that is AS. So what is AC? AC is A. So A minus CS is equal to AS. And what is AS? AS is nothing but E into AZ. So AC minus CS is equal to E into AZ. That means E into AZ is nothing but A minus CS. Correct? So this is one point we get. So now E into AZ, what is AZ? AZ is nothing but CZ minus AC. That is equal to A minus CS. So that implies E into CZ minus AC. What is AC? AC is A. So E into CZ minus A is equal to A minus CS. That implies E into CZ plus CS is equal to A plus AE. Very simple thing. You may need some time to understand, but it is very straightforward. Now you may have a question, sir, why it is the way to derive? Because we are going to find the locus, and that is why it is required. Now, so we get that equation 1. What is that? E into CZ plus CS equal to A plus EZ. In the similar manner, dear students, that A dash C plus CS is equal to A dash S. That implies A plus CS is equal to E into AZZ. That implies E into AZZ is equal to A plus CS. So what we get? Now what is A dash Z? A dash Z is nothing but, CZ plus, A dash C. If you see that, A dash Z, if you look into that A dash Z, A dash Z is nothing but that CZ plus A dash C, that is equal to A plus CS, which I wrote it here. So eventually what we get, E into CZ plus A is equal to A plus CS, and we get E into CZ minus CS is equal to A minus AE. And these two are very important information, dear students. What is that? The first one is that E into CZ plus CS is equal to A plus AE. And the second one is that E into CZ minus CS is equal to A minus AE. So we get these 2 points, these 2 equations, dear students. Once we get these 2 equations, then what we can do is that, let's add these 2 equations. If we add these 2 equations, what we are going to get? We are going to get that 2 into E into CZ is equal to 2A, and eventually we get CZ is equal to A by E. Very straightforward. Let me write it down. So what I just said, and here it is a mathematical description. What is that? Is that if you add the above 2 equations 1 and 2, what we get is that 2 into E into CZ is equal to 2A, and we get CZ is equal to A by E. Correct, dear students? So we get CZ is equal to A by E. Now, and if we subtract the above equation 2 from the above equation 1, so first we did addition. Now what we are going to do, we are going to, by subtracting the above equation 2 from the above equation 1, what we are going to get, dear students? We are going to get something like this. And here it is. What is that? What we get is that 2 into CS is equal to 2 into AE. So what we are going to get, dear students, 2 into CS is equal to 2 into AE, and eventually we get CS is equal to AE. Now, dear students, if you look into this, above equation, 3 and 4, we get the coordinate of the point x. And what is that? That is minus AE comma 0. And also we get the equation of the directrix as AX is equal to minus A by E. That is two very important observation, because C is nothing but the center. So what we can get, these are the two very important information, and to derive this important information only, we made so many previous steps to come to this one. So what I'm saying is that it's something like this. Now if we solve this equation 3 and 4, you no need to solve, just by looking into the equations 3 and 4, what we can say is that the focus is minus AE comma 0, and equation of the directrix as x is equal to minus A by E. Dear students, it may possible that, okay sir, the picture is not in front of me, so I'm not able to make a great sense out of it. So let me place the picture in front of you, dear students. Okay, if I place the picture in front of you, then you can make you can understand now. So what we see, dear students, that what we got is, what we get is that minus AE comma 0, okay, and x is equal to minus A by E. So that is the equation. That equation of the directrix, what we get is that x is equal to minus A by E, and what we get, the coordinate of the focus is that minus AE comma 0. Now, dear students, if you look into it very minutely, okay, what we get is that we are now very we are just few steps to find the equation of that ellipse. How it is, let me show you. Now, as you notice that we took that point P as alpha beta, an arbitrary point. Why it is arbitrary point? Because it can move, and it can move subject to the geometrical condition that PS by PM equal to E, which is less than 1. So now, as P is the arbitrary point having coordinate alpha comma beta, so then by means of the property of ellipse, what we get, PS by PM is equal to E. And eventually what we get, dear students, is that okay, just a minute, let me place it very properly. PS is equal to PS by PM is equal to E. That is for sure, that you understood. PS by PM is equal to E, that we already understood. That is what the fundamental definition of an ellipse is. So eventually we made a square of both the sides, and we get PS square is equal to E square PM square. Now we know the coordinate of the point S, we know the coordinate of the point P, so it is not a big deal to find the value of PS, in fact PS square. And we know the coordinate of the point P, and we know the equation of the directrix, that straight line, so it is not a big deal to find the perpendicular distance from the point P to the straight line. So what we get, dear students? So we get something like this if we simplify. Let me show you step by step, so that you get it very clearly. Okay, so we know that PS square, we can find it out, as you see, dear students, here. And we can also find that PM, because we know the equation of the directrix as x equal to minus A by E. So we find it out and we make a square and we get this thing. After that, it is just a simplification. And if we simplify, then I'm going to show you the simplification, and we get something like this. just algebraic simplification. Correct, dear students? I hope it is self-explanatory that all this, simplification. Then eventually what we get, dear students, we are going to get alpha square by a square plus beta square by 1 minus e square is equal to 1. Correct? So what we get? We get something like this. Alpha square by a square plus beta square by 1 minus e square equal to 1. So now we are introducing another term called b, which is expressed in terms of a and e. That is alpha square by a square plus beta square by b square equal to 1, where alpha square by a square plus beta square by b square equal to 1, where b square is nothing but a square into 1 minus e square. Correct, dear students? So b square is equal to a square into 1 minus e square. After that, what happened is that, so the locus of the point alpha comma beta, that is the equation of the ellipse. What we can get? Just replace alpha by x and beta by y, and we get the equation of that ellipse is something like this. Let me show it to you. X square by a square plus y square by b square equal to 1. Dear students, that is very, very important. So what we can say is that the locus of the point alpha comma beta, so let me place it here actually, that is the right place. So as we get alpha square by a square plus beta square by b square equal to 1, where b square equal to a square into 1 minus e square. So what we get? The locus of the point P, that is alpha comma beta, that is the equation of the ellipse, is actually x square by a square plus y square by b square equal to 1, where b square is equal to a square into 1 minus e square. And you get the equation of the ellipse. That is a very important one. So dear students, whenever you get equation something like this, x square by a square plus y square by b square equal to 1, in which b square equal to a square into 1 minus e square, we can say this is an equation of an ellipse with eccentricity e. Okay, now what are a and b? That we are going to discuss now. What are a and b? That we are going to discuss, and that we'll discuss in details. Okay. Now, there are few important points that I'm going to, tell you, and after that I will discuss with you that different attributes of ellipse. And what about the points I'm going to mention you are very important points and little advanced points. So if you remember this thing and apply as and when required in solving, questions related to ellipse, it will be very meaningful. What are those points, dear students? So I am going to, inform you one by one. The first point, what it says that whenever we see that equation x square by a square plus y square by b square equal to 1, where b square is equal to a square into 1 minus e square, we see that x is in between minus a to a and y is in between minus b to b. Okay, it follows that ellipse is a bounded curve. How? Because x is actually bounded between minus a to a. Unlike parabola, parabola is not bounded. It is, one end is open. And also y is in between minus b to b. Okay, hence it is a bounded curve. So I can show you this thing by means of this, diagram. What you see, if you see here, dear students, that that this is the point A and this is the point A dash. So that x can vary between these 2 points. That extreme point A and other extreme point A dash. The x coordinate of the point A to x coordinate of the point A dash is the the variation of the x coordinate of the ellipse. And similarly, if you see that this is the point B and this is the point B dash, then what we get, dear students, that is that y coordinate of the point B and y coordinate of the point B dash, that is the entire variation of the y coordinate. And hence we say something like this, that the first point, that x is in between minus a to a and y is in between minus b to b. Second point is that ellipse is a central conic and its center can be obtained by solving the partial differential equation. Dear students, many of you are not aware about the partial differential equation, but let me give you a very brief idea about the partial differentiation. What you see, that equation of an ellipse, it contains two variables, x and y. Okay, so let me first tell you what is partial differentiation. If xy equal to 0 is the equation of the ellipse. Okay? Now, what is delta f, delta x? It is a partial differentiation of f xy equal to 0, keeping y is constant. Okay, so that means with respect to x, that is a differentiation of f of xy equal to capital F of xy equal to 0, with respect to x, keeping y as constant. In the similar manner, we can find delta f, delta y. The moment we find delta f, delta y, as if that we are differentiating that function capital F xy equal to 0. Capital F xy means it has two variables, x and y, but we are just concentrating on only one variable. When we finding delta f, delta y, that time we are only concentrating on the variable y, keeping x as constant. That is what is called partial differentiation. Okay, so ellipse is a, so what is the second point? Let me read out, dear students. Ellipse is a central conic and its center can be obtained by solving the following equation of the partial differentiation. And the third point, dear students, is that the area of the ellipse x square by a square plus y square by b square equal to 1 is pi into a into b. That is the area of the ellipse. That x square by a square plus y square by b square equal to 1 is pi ab. Now, dear students, what I'm going to discuss is that different attributes of ellipse. Okay.
Sir,
Yes, please.
central conic. I don't.
Okay. Ellipse is a central conic. Central conic in the sense, first of all, thank you very much for asking the question. Central conic means is that it is a conic, in which you have it's a center point. Okay, so it is surrounded by that. That means what it is. If you just imagine that equation of a parabola, it is central in the sense is that this is a midpoint. That is why it is called central conic. It is bounded. Got it?
Yes.
Okay. Thanks for asking question. Now, dear students, what I'm going to discuss, and that is very important one, is called the different attributes of an ellipse. Or what are the different attributes? Attributes in the sense, dear students, what are the attributes? Attributes is called the directrix, focus, major axis, minor axis. That I'm going to discuss with you now. Okay, so one by one, and this is very important, extremely important, I can say, and you need to remember this thing to solve problems. And every year problem comes, and you need to remember these attributes very well. Otherwise, we will not able to make sense that what attributes mean by what. So the point what I wrote here, dear students, is that now let us see the following different attributes of the ellipse x square by a square plus y square by b square equal to 1. The first one is that the ellipse has two foci, that is the plural number of focus. The ellipse has two foci and also two directrix. This is because the ellipse is symmetric about y-axis. Let me show you. Okay, this is the ellipse is symmetric about y-axis. Which ellipse is symmetric about y-axis? That x square by a square plus y square by b square equal to 1. Why it is so? Let us understand. So I just want to take you to the the previous page where I drawn that equation of that ellipse. If you look into it, dear students, so let me increase the font. I think this is sufficient. If you see, dear students, here that this is one focus, that is also another focus, S dash, and this is one directrix NZ, and that is another directrix N dash G dash, that is also a directrix. If you recall, in parabola we got only one directrix and one focus, but in case of ellipse there are two foci, that is the plural number of focus, and two directrices. And that's what I want to do actually mention in the first point. The ellipse has two foci and two directrices. This is because the ellipse is symmetric about the y-axis. Why ellipse is symmetric about the y-axis? As I was telling, as you see the diagram, why ellipse is symmetric about the y-axis? Because along that y-axis, symmetric means what? If you recall the symmetric topic, what you have studied in your previous earlier classes, that along that y-axis, if you keep one mirror, then, and if you just have the one part of that, just you have the one part of that ellipse, then you can get the other part. The image will get the other part. And that's why it is symmetric about the y-axis. And dear students, it is also symmetric about x-axis as well. That means what? Along that x-axis, if you keep one mirror and you just have the one part of that ellipse, okay, you will get the other part. Correct, dear students? So this is about the symmetric about the y-axis. The next point what I'm going to discuss, dear students, is that the line passing through the foci is called the major axis of the ellipse. So the major axis perpendicular to both the directrix of the ellipse. So dear students, I think it is better that if I bring that equation of the ellipse here, if I can bring the the picture, the diagram of the ellipse here, so that it will be much more meaningfully to you to understand what I'm talking about. So let me bring that one. Yeah. If you see, dear students, here what I'm mentioning is that this thing, if you look into that ellipse, that the line passing through the foci, that means these are the two foci, dear students, one is that S and the other one is that S dash, that is called the major axis. So in context to the ellipse, x square by s square plus y square by b square equal to 1, then what we say is that x axis is the major axis, and so the major axis is perpendicular to both the directrix of the ellipse. Obviously nj and n dash z dash are the two directrices, so it is perpendicular. So this is well understood. Correct, dear students? Now the next point what I'm going to discuss with you is that just a minute, let me keep it from that study material. And dear students, the next point what I'm going to mention is something like this. The line perpendicular to the major axis and passing through the center of the ellipse. The line perpendicular to the major axis and passing through the center of the ellipse is called the minor axis. So obviously it is in this case, y is the minor axis. So this is the next point. Now the next point is the distance between the point of intersection of the ellipse with its minor axis is called the length of the minor axis. So in this case, b dash is the minor axis, length of the minor axis, correct? So let me read out once more. The distance between the point of intersection of the ellipse with its minor axis, which is the y-axis in this case, is called the length of the minor axis. And the distance between the point of intersection of the ellipse with its major axis is called the length of the major axis. That is A dash is called the length of the major axis. Correct? And a line passing through the focus and perpendicular to the major axis. I repeat, a line passing through the focus and perpendicular to the major axis of the ellipse is called the latus rectum of the ellipse. As there are two foci, so eventually there are two latus rectums. So one latus. So let me show you this thing. A line passing through the focus and perpendicular to the major axis. That means this is the line. Okay, this is the line. So let me show you the line. Let me show you the line in a different color. Let me show you in the blue color. So this is what you see, dear students. This is one latus rectum. This is another latus rectum. So there are two latus rectums because there are two foci. Correct, dear students? So now, so this is about the different attributes of an ellipse. Now, we can change the major axis and minor axis, dear students. Okay, so that if we shift that major axis and minor axis, we get different forms of ellipse. And for these different forms, we can have, the different center will be same, by the way. There will be different foci, different directrices, major axis, minor axis, length of major axis, length of minor axis, and that I am going to show you, length of the latus rectum and eccentricity. And I am going to show you by means of a diagram. And that I'm going to show you, and you need to remember this diagram very well, dear students, and that I'm going to show you in the next page. And this table is very important, and if you remember this table, then you see that 50% of the problem on ellipse is actually very clear to you. What is this, dear students? So let me read it out. Okay, and also you can actually, once the class is done, once you have your own time, you can actually go through all these attributes, and you can actually get a clear understanding. If you draw the equation of the ellipse and whatever I taught so far, if you actually just go through it, you will have a very clear idea that why these are the different coordinates and values of the attributes. So what, dear students? So here it is, that now depending on the selection of the major and minor axis, depending on the selection of major and minor axis, okay, the standard form of an ellipse and its different attributes may vary as shown in the following table. So first equation is that x square by a square plus y square by b square equal to 1. A greater than b, definitely one form. And x square by b square plus y square by b square equal to y square by a square equal to 1. Here also a greater than b, but if you see the difference between these two, x and y are got interchanged. So now the first attribute is center. Center remains the same for both these forms of ellipse. Foci is actually, for the first one is plus minus a comma 0. That means one is a comma 0, the other one is minus a comma 0. But in case of second form, it is 0 plus minus a. Third one is the equation of the directrix. For the first form, it is x equal to plus minus a by e. And for the second form is equal to x is equal to plus minus, y is equal to plus minus a by e. Equation of the major axis for the first form is y equal to 0. And the second form is x equal to 0. And equation of the minor axis for the first form is y equal to 0. Sorry, equation of the minor axis for the first form is x equal to 0. And the second form is y equal to 0. Length of major axis for the first form is 2a. And the second form is also 2a. Length of the minor axis for the first form is 2b. And the second form is also 2b. Length of the latus rectum for both the cases is 2b square by a. And the relationship between AB and eccentricity is that b square equal to a square into 1 minus e square. Dear students, as I said few minutes back, once the class is done, you can draw this ellipse, different, the geometrical shape of this ellipse for both the forms, and just go through the way I explain the standard form and the general form, and you have your idea very clear why these are the coordinates of these different attributes and the length of major axis, minor axis, latus, rectum, and eccentricity. Okay, dear students, so with this note, I would like to conclude the class for today. In the next class, that is tomorrow, we will be discussing that equation of ellipse in origin shifted form, then parametric form, an auxiliary circle, focal distance, alternative definition of ellipse. Then we will discuss about the position of a point with respect to ellipse, tangent, director's circle, and we will discuss about the, you know, normal of ellipse, chord joining 2 points of an ellipse, and pair of tangents from an external point, chord of contact in terms of middle points. All these things we will be discussing in our class tomorrow and subsequent classes. With this note, dear students, I would like to conclude the class for today, unless you have any specific question for me. Thank you very much.
Thank you.
Thank you.